Ladies and gentlemen, the lecture will begin in a few minutes. Please kindly take your seats. Please remember to set your mobile phones to silent mode. Thank you. 各位来宾，唐奖得奖人演讲永续发展场即将在几分钟后开始，请您尽速入座。今天的演讲将全程以英文进行，聆听中文的翻译内容，请将同步口译接收器频道切换至1，并请记得将您的手机调整为静音模式。谢谢。
Political and moral philosophy.
He was a model of a philosopher. He was just like the statues from Athens. That was how I remember thinking the first day. Socrates, Plato, Aristotle, Raz.
Born in 1939, Raz started his philosophical pursuits at an early age. He graduated from the Hebrew University of Jerusalem, followed by a Doctor of Philosophy in Oxford. Raz grounds his theories in reason, that each individual is an autonomous being, in further developing his theses on the nature of law, authority, and political liberty.
So from the beginning of my life as a student, or as a school kid, I wasn't interested in legal philosophy specifically. I was interested in philosophy, and that's never changed.
Raz spent most of his career in Balliol College, Oxford, tirelessly teaching, researching, and writing for over 50 years. His writings break new ground in thought regarding the relations between individuals and societies, the role of public authorities, the nature of law, and the rule of law.
Ladies and gentlemen, the lecture will begin in a few minutes. Please kindly take your seats. Again, please remember to set your mobile phones to silent mode. Thank you. 各位来宾，今天的演讲即将开始，在这边邀请您尽速入座，同时也请记得将您的手机转为静音模式。谢谢。 Ladies and gentlemen, please give a warm welcome to the laureates of the 2018 Tang Prize in Sustainable Development, Dr. James Hansen, Dr. Veerabhadran Ramanthan, and our host, Dr. Chao Han Liu. Good afternoon, distinguished guests, ladies and gentlemen. Welcome to the Laureate Lecture of the 2018 Tang Prize in Sustainable Development. To begin with, we would like to invite to the stage the host of this lecture, Dr. Chao Han Liu, academician of Academia Sinica, to give us the introduction. Ladies and gentlemen, please give a warm welcome to Dr. Liu.
Good afternoon, ladies and gentlemen. It's my honor, my pleasure to introduce to you two master lecturers for this afternoon on the Sustainable Development category of the Tang Prize of 2018. Let me first say a few words about this particular category. As many of you probably know, the Earth, our planet, is now into the so-called Anthropocene epoch, which is a period, a geological period, in which human activities have been the dominant influence on the condition of the planet. Science and technology actually have been the main driver behind this influence. And as we all know, they have brought many much needed and timely benefits to human society over the years, over the ages, helping us shape our civilization. But they also led the human society to a path where we now have to face an existential problem. That problem is, can human beings, human society, as we know it, be sustained? Human beings have brought ourselves into an abyss. Can we find ways to avoid the Armageddon? The Tang Prize for Sustainable Development is designed to help us to answer this question. The prize is awarded to those who have made extraordinary contributions to the sustainable development of human societies especially through groundbreaking innovations in science and technology. And the prize is, as we all know, quite multifaceted. It includes areas such as energy, climate, biodiversity, engineering, as well as science policies related to sustainable development problems. In particular, the prize is awarded to persons who have made similar contributions to the science itself, as well as they have applied the knowledge to try to solve the problems, the sustainability problems. This year, the prize was awarded to 2 climate scientists who fit perfectly into this description. Dr. James E. Hansen and Professor Veerabhadran Ramanthan. Dr. Hansen was awarded for sounding the alarms, on climate change, elucidating the physics of climate forcings and feedbacks, and quantifying the dangers of global warming and tirelessly advocating meaningful action and solutions. Professor Ramanathan is awarded for making similar contributions to our fundamental understanding of climate change and impact of air pollution, and taking direct action to advocate and facilitate effective mitigation solutions, policies. And now, the 2 laureates today will give us the master lectures. First one is Professor Tmc Henson. I'll briefly introduce him to the audience. Dr. Hansen was born in Iowa, United States. He studied at University of Iowa and received his PhD in the university under Professor Van Allen in 1967. He worked at NASA's Goddard Institute for Space Studies, GISS, for more than 30 years. And he has been at the forefront of advocating scientific understanding, advancing scientific understanding of the climate change phenomena. He was the first to detect the greenhouse warming signal on the Earth, and he was the first to warn the world of the danger of the intensive storms and extreme weather events in the future. And his advocacy of action to avoid dangerous climate change has inspired many people, especially young people around the world, to join the fight to mitigate the climate disaster in the world. Today, he will talk to us about global change, global energy, climate, and health, young people's burden and opportunities. Ladies and gentlemen, please join me to welcome Dr. Hansen.
Thank you. I'm glad to see some young people in the audience. This is really all about you and the planet that we're leaving for you. Energy enriches our lives. 1 liter of petrol contains the work equivalent of 100 hours of labor by a healthy adult. Fossil fuels powered the Industrial Revolution, raised living standards, and helped eliminate poverty. Fossil fuels also affect the climate and human health, leaving young people burdens that must be turned into opportunities. That requires an understanding of science and technology. Let's start with the climate story. So what do I know that would cause me, a soft-spoken Midwestern scientist, to get arrested protesting in front of the White House? I was lucky to grow up at a time when it was not difficult for the child of a tenant farmer to make his way to a state university. And I was especially lucky to study under Professor James Van Allen, who built instruments for the first United States satellites at the University of Iowa. Professor Van Allen told me about observations of Venus. Venus was emitting intense microwave radiation. Did it mean that Venus had an ionosphere, or was Venus extremely hot? The right answer, confirmed by Soviet Venera spacecraft, was that the surface was very hot, 900 degrees Fahrenheit, kept hot by a thick carbon dioxide atmosphere. Mars, Earth, and Venus confirm the greenhouse effect. The greenhouse effect is the excess temperature relative to what is expected given the amount of sunlight each planet absorbs. And as the greenhouse gas amount increases, excess warming increases. Earth is not too cold or too hot. It's just right for life. I was fortunate to join NASA and successfully propose an experiment to fly to Venus. Our instrument, which is a telescope 1.5 inches in diameter, took this image of the veil of Venus, which turned out to be a thick smog of sulfuric acid. While our instrument was being built, I became involved in calculations of the greenhouse effect here on Earth because we realized that our atmospheric composition was changing. So I resigned as the principal investigator on our Venus experiment because changes on our own planet are more interesting and important. They will affect all humanity. The greenhouse effect had been understood for a century. Irish physicist John Tyndall in the 1850s made laboratory measurements of infrared radiation, which is heat, and he showed that gases such as CO2 absorb heat, thus acting like a blanket, warming Earth's surface. I worked several years on climate observations and building a climate model with colleagues. In 1981, we published an article in Science magazine concluding that Earth had warmed 0.4 degrees Celsius in the prior 100 years. That observed warming matched our calculated warming due to increasing CO2. That Earth would warm more in the 1980s, and that warming would exceed natural variability before the end of the century. We also said that the 21st century would see shifting climate zones, creation of drought-prone regions in North America and Asia, erosion of ice sheets, rising sea levels, and opening of the fabled Northwest Passage. All of these have since occurred. That paper was reported on the front page of the New York Times and led to me testifying to Congress in the 1980s. Testimony in which I emphasized that global warming increases both extremes of the hydrologic cycle. Heat waves and droughts on one hand, directly from the warming, but also because a warmer atmosphere holds more water vapor with its latent energy, rainfall can occur in more extreme events. There are stronger storms and greater flooding. After I complained that the White House had altered my testimony, global warming hoopla became time-consuming and distracted me from doing science. So I decided to go back to strictly doing science and leave the communication to scientists who were good at media communication and even enjoyed it. By 15 years later, evidence of global warming was much stronger. Most of the things mentioned in our 1981 paper were established facts. I was privileged to speak twice to the President's Energy Task Force, Vice President Cheney, and 6 cabinet members. But U.S. energy policy continued to focus on fossil fuels. At the same time, my view of the safe level of atmospheric CO2 began to diverge sharply from that of prominent climate science communicators. And by then, I had 2 grandchildren. I decided that I did not want them in the future to say, Opa understood what was happening, but he didn't make it clear. So I decided to make a public statement criticizing the lack of an appropriate energy policy. After I encountered resistance to giving the talk in Washington, Professor Van Allen kindly arranged for a lecture at the University of Iowa in October of 2004. And 14 months later, I gave a similar talk at the 2005 American Geophysical Union meeting. That talk led to several calls from the White House to NASA headquarters. And I was told that I could not give any more talks or speak with the media without explicit prior approval by NASA headquarters. After I informed the New York Times about these restrictions, NASA was forced to end the censorship. But there were consequences. I had used the first line of the NASA mission statement to understand and protect the home planet to justify my talks. Soon, this line of the mission statement was deleted, never to appear again. In the next few years, I was drawn more and more into communicating the urgency to change energy policies, while still researching the physics of climate change. Let me describe two of the most important pieces of that physics. Adding CO2 to the air is like throwing another blanket on the bed. It reduces Earth's heat radiation to space. So there is an energy imbalance, more energy coming in than going out, until Earth warms up enough to again radiate to space as much energy as it absorbs from the sun. Earth's energy imbalance is the key quantity. If more energy is coming in than going out, then more global warming is in the pipeline, and it will occur even without any more greenhouse gases. We can now measure Earth's energy imbalance by measuring the heat content in Earth's heat reservoirs. The biggest reservoir, the ocean, was the least well measured until more than 3,000 Argo floats were distributed around the world's oceans. These floats reveal the upper ocean is gaining heat at a substantial rate, and the deep ocean at a smaller rate. Energy is also going into net melting of ice around the planet, and the continents to depths of tens of meters are getting warmer. The total energy imbalance is now about 3/4 of a watt per meter squared. That's about 20 times greater than the rate of energy use by all of humanity. It's equivalent to exploding about 500,000 Hiroshima atomic bombs per day, 365 days per year. That's how much extra energy Earth is gaining each day. This imbalance means there is more warming in the pipeline without additional CO2. It also means if we want to stabilize today's climate, we must reduce CO2 from 410 parts per million to at most 350 ppm. That's the change needed to restore energy balance. Climate change deniers argue that the sun is the main cause of climate change, but the measured energy imbalance occurred during the deepest solar minimum in the record, when solar energy reaching Earth was least, yet more energy was coming in than going out. So the effect of sun's variability is overwhelmed by the increasing greenhouse effect due to fossil fuel burning. Earth's history contains remarkable information on climate change. Global temperature, atmospheric CO2, and sea level over 800,000 years can be derived from ocean cores and Antarctic ice cores, from ocean sediments and from the snowflakes that pile up year after year and form a 3-kilometer thick ice sheet. Sea level is a measure of ice sheet size. When the ice sheets melt, sea level rises. Climate change on such long time scales is instigated by oscillations of Earth's orbit and the tilt of the Earth's spin axis, which alter the seasonal and geographical distribution of sunlight on Earth. These orbital forcings are weak and slow, changing on time scales from 20,000 to 100,000 years. Climate changes on these long time scales are very large. The large magnitude is due almost entirely to two powerful amplifying feedbacks, ice sheets and CO2. As Earth warms, ice melts and exposes darker ground that absorbs more sunlight. As the ocean warms, it releases CO2 like a warm Pepsi. CO2 changes more slowly than ice sheets, so it is the control knob on global temperature, as you can see from this remarkable comparison of atmospheric CO2 and Antarctic temperature. The same amplifying feedbacks must occur today. Physics does not change. As Earth warms, ice sheets will melt. CO2 and its companions, methane and nitrous oxide, will be released by warming ocean, melting tundra, and wetlands. We can't say exactly how fast these amplifying feedbacks will occur, but they will occur. Now let's tack modern data onto the paleo record. CO2 is shooting off scale. Temperature is also rising, but it has not caught up to the CO2. That takes time. Why? First, the ocean has great thermal inertia. It takes 100 years for the ocean surface temperature to reach 2/3 of its equilibrium response. Second, there are slow feedbacks. Ice sheets do not melt overnight. The paleoclimate record shows sea level lagging temperature by a few centuries. So does that mean that coastal cities are safe for several centuries? No, because human-caused change in greenhouse gases is much faster than any change in Earth's history. In our paper, Ice Melt, Sea Level Rise, and Superstorms, we estimate that multimeter sea level rise can occur in 50 to 150 years if CO2 continues to increase rapidly. Sea level rise does not need to reach several meters before the economic impact becomes intolerable and the world likely becomes ungovernable. Cities become dysfunctional long before they are totally underwater. These are all the world's largest cities. As you can see, more than half of them are on coastlines. Florida, the Netherlands, and Bangladesh would be underwater, and a good part of China. The second irreversible impact of rapid, large climate change would be on other species. We cause stress on other species in many ways as we take over the planet. We could commit to extinction 1/4 to 1/2 of all species from the combined effect of these stresses and rapidly shifting climate zones, according to estimates of the Intergovernmental Panel on Climate Change. Coral reefs are the rainforest of the ocean, harboring more than 1 million species. They are threatened by many stresses, including ocean warming, which causes coral bleaching, and ocean acidification, which in the extreme can dissolve the carbonate exoskeletons. We are losing more than 1% of the coral each year. If rapid emissions continue, especially with rapid sea level rise, most coral could be lost. However, if we reduce CO2 emissions to stabilize shorelines, we will also solve this problem. Older people notice that climate is already changing, especially in the summer. Year-to-year variability of seasonal temperature in the 20th century formed a nice bell curve about the average. But now that bell curve has shifted. What was an unusual extreme hot season last century is now much more likely to occur. The change depends on location. In middle latitudes, in the US and Europe, the shift is a bit more than 1 standard deviation in summer, but smaller in winter. In the subtropics, such as the Mediterranean and Middle East and Southwest United States, every summer is now hotter than average climate 50 years ago. And that's almost true in Southeast Asia today. Increased heat causes dry regions to have more drought and wildfires and a longer fire season. But warm air holds more water vapor, so wet regions and rainy seasons can have more extreme rain and floods. Low latitudes are becoming less livable outdoors in the warm season. And more than half of the jobs are outdoors in agriculture or construction. Higher temperatures also lead to a measurable increase in violence. These things are happening. Dry regions are having more extreme events. Here are fires in Greece this year. These are more images from the fires in Greece. Fires have always occurred, but despite massive efforts to extinguish fires in the US, the area burned is increasing. 100-year floods are now occurring more than once a century. There was unprecedented rainfall amounts in Japan this year. A warmer ocean surface and more water vapor in a warmer atmosphere provide more fuel for stronger tropical storms, tornadoes, and thunderstorms. This super typhoon had the strongest sustained winds over land ever recorded, reaching 195 miles per hour, which is well over 300 kilometers per hour. Yet the urgency of the climate crisis is not recognized by most people, by most of the public. Because of the ocean's thermal inertia, much of the warming is still in the pipeline, and that warming will drive slow feedback, such as melting of permafrost and ice sheets. So, if the world does not reduce fossil fuel emissions, it will be an injustice to young people, because we will hand them a situation out of their control. It also would be an injustice of the industrial North, which is burning the allowable carbon budget for the entire world. And, of course, an injustice of humans to all other species. Okay, now you know why I got arrested. After I was arrested 5 times, I finally realized, hey, this is not working. Drawing attention to the injustice of climate change does not alter government policies. Energy use continues to grow. People want to raise living standards. People want to travel, and they will. They need air conditioning. The world needs energy. Governments give large subsidies to renewable energies and pretend this will cause fossil fuel use to decline. As you can see, the fossil fuel use continues to increase. Courage to use the true scientific method is lacking. So governments continue to seek fossil fuels, and there are plenty to find. We have burned only the purple portion so far. The science is crystal clear. we must leave most of the remaining carbon in the ground. And we must extract some CO2 from the air, which is possible via improved agricultural and forestry practices. However, we must leave young people a feasible task and tools to address it. Young people must take up the fight and they must demand their rights. But to succeed, they must understand the matter and use the scientific method. We old scientists failed to change the world's course. I hope to explain to young people what I learned in Sophie's Planet, a book that I'm writing. And thanks to the Tang Prize, I should be able to finish that book very soon. The core of the scientific method is simple in principle. You must use all the data. Be very skeptical of your interpretation and honestly reassess from scratch when new data becomes available. Your preference, your ideology must not affect your assessment. So it is difficult. Now let's consider human health as another huge issue associated with energy. China did an inadvertent experiment by providing free coal for winter heating to people in North China for several decades. It reduced their life expectancy by 5.5 years. Globally, outdoor air pollution, mainly from fossil fuel burning, is killing more than 3.5 million people per year. That's 10,000 people per day. The aerosols that people breathe are so tiny that they enter the bloodstream, causing cardiac problems as well as respiratory problems. Indoor air pollution from burning coal, wood, and other biofuels kills an additional 3.7 million people per year. And because these fuels are used for cooking, women and children are especially affected. Many of the deaths from air pollution are prolonged and painful to the victim and the family. The crucial requirement to solve both health and climate problems is abundant, clean, carbon-free energy. However, fossil fuels will not be replaced by an alternative unless the entire energy system is economic relative to coal and gas, including costs of additional transmission lines and energy storage if those are necessary. India will soon pass China in population, and India will pass the US in carbon emissions, becoming second to China. Renewable energy, the green area, provides only a tiny portion of the energy. It cannot stop growth of fossil fuels, let alone cause their phase out. Energy history of the United States is educational. Wood was the first energy source, but coal with greater energy density powered the Industrial Revolution until the more convenient liquid and gas fossil fuels were discovered. Because fossil fuels are a finite resource and a big pollution problem, it was hoped that peaceful use of nuclear power would be a major long-term energy source. There is enough nuclear fuel in the ocean to last forever, for billions of years. So it would be possible to stop mining of uranium or thorium. Nuclear power could potentially eliminate CO2 emissions as well as air and water pollution. However, development of nuclear power practically stopped in the 1970s. What happened? The root problem for nuclear power is concern about health effects of atomic radiation. Until 1956, it was assumed that there was a threshold for harm, consistent with the idea that radiation is probably not dangerous if it is less than the amount that we get from cosmic rays and radioactive elements in the soil. Some scientists even argue for radiation hormesis, the idea that low levels of radiation are beneficial. However, in 1956, the National Academy of Science Baer Committee, Biological Effects of Atomic Radiation, declared that the tiniest amount of radiation is harmful. Linus Pauling used the idea that even the tiniest radiation is harmful to help achieve a ban on atmospheric testing of nuclear weapons by the US and USSR. This, incidentally, had an effect on public perception of nuclear power. Public attitudes were also affected by the 1979 disaster thriller, The China Syndrome, about the danger of a nuclear meltdown. The film almost coincided with an actual accident and partial core meltdown at the 3 Mile Island power plant in Pennsylvania. Enthusiasm for nuclear power in the US dissipated, even though it was determined later that the radiation release did not harm Pennsylvania residents. This is from a concert held that year in New York.
I want the energy that we have now. We have to have either oil or coal or whatever, but certainly not nuclear. Even wood if need be. I have a coal stove at home if you want to know. Flash! Yes. Put it on. I don't use it now, but if I have to, I will. And I live 1 block from the mayor, and I have a coal stove. Put that in your house and smoke.
Song of our movement. Just give me the warm power of the sun. Give me the steady flow of the waterfall. Give me the spirit of living things as they return to clay. Just give me the restless power of the wind. Give me the comforting glow of the wood fire. But please take all your atomic poison power away. Take all your atomic poison power. Take all your atomic poison power away.
So did you hear the line in the song, "Give me the warm glow of a wood fire"? Remember that 10,000 people per day are dying from indoor air pollution. Proponents of nuclear power continue to argue that the Baer Committee was wrong, that LNT is not correct and was ideologically driven. I doubt that this battle will be fruitful. Small radiation effects are difficult to prove and depend on the circumstances. In such case, health professionals are likely to prefer the strictest criterion, which is LNT. However, young people have a good basis to be very unhappy with us old people for not being scientific, for not being objective. We owe it to young people to provide an honest comparison of the health and environmental effects of nuclear power, health and environmental effects of fossil fuels, and health and environmental effects of renewable energies. We have science academies capable of such evaluations, which should be presented side by side. Young people have more reason to question the wisdom of us old people. President Clinton, 25 years ago, terminated R&D on nuclear power, just when the Department of Energy was ready to build an advanced generation nuclear reactor with major improvements over today's reactors, which are 50-year-old technology. Nuclear power in the US has an outstanding safety record, but next-generation nuclear power can be even much safer and produce less nuclear waste. We would not force solar energy or windmills to use 50-year-old technology. I am not advocating any specific technology. My opinion is that because of prior government failure to support R&D, the best chance now for advanced technology to contribute to rapid phase down of CO2 emissions in the near term is probably via modular light water reactors. However, the Nuclear Regulatory Commission and the Department of Energy need to facilitate progress with modern technology, which they are not doing well. Canada has a more responsive regulatory commission. Yet from an engineering perspective, the best nuclear innovation potential still seems to be in the US. So let me give the last word on this topic to my oldest grandson. Here he's at about age 7, reading an Indiana Jones book about an urgent problem. A few years later, Connor correctly identified two basic conclusions about the energy-climate matter. First, if grown-ups keep doing what they're doing and kids can't figure out a time machine that actually works, then kids are screwed. Second, some grown-ups are scared of nuclear power, but what about fossil fuels? We know that using fossil fuels is not safe. It is very dangerous. Now, let's consider the solution to the health and climate problems. The essential requirement is a rising carbon fee to make the price of fossil fuels honest by including their human health and climate change costs. It's easy to implement an across-the-board carbon fee, collecting it at the first sale at domestic mines and ports of entry. If 100% of this collected fee is distributed equally to all legal residents, we obtain a simple, transparent, market-based approach that spurs innovation. With the present distribution of energy use, 70% of the public will make money. But if they want to stay on the positive side of the ledger, they need to pay attention to the price of things on the shelf. Products that employ a lot of fossil fuel in their production will become more expensive. Most rich people have a large carbon footprint from large houses and flying around the world, so they will lose money, but they can afford it. Fee and dividend spurs the economy, creating jobs, increasing GNP, and increasing government revenue. Fee and dividend is the one effective international approach. When the US and/or China adopt a carbon fee, they will also impose border duties on products from countries that do not have an equivalent carbon fee. That will be an incentive for other countries to adopt a carbon fee so they can collect the money themselves. So the crucial underlying requirement is a rising price on carbon to make the fossil fuel price honest. Some regulations will still be required, and governments should support research and development because it is essential to have 100% carbon-free electricity. It's important to recognize national responsibilities for climate change, which is proportional to cumulative emissions. The US, the UK, and Germany are much more responsible for climate change than the developing countries. In other words, the West burned much more than its fair share of the global carbon budget that is permitted if we are to stabilize climate and avert disasters. This is an added reason for the West to assist in reducing emissions in developing countries, in addition to the fact that we're all in the same boat together. How can we reduce emissions from the big future emitters? If I want to be popular, if I want to find research support easily, I must say that renewable energies can provide all of our energy. If I want to be a good scientist, I must look at the data. Does it make sense to place all of our eggs in one basket, to make the assumption that renewable energies by themselves will rapidly replace fossil fuels? Young people should be angry. Old people do not have the right to gamble the future of young people on that assumption. I doubt that the climate problem will be solved by 190 nations sitting around a table. What is required, I believe, is the United States and China to agree on the need for a carbon fee. They could readily impose it on a near global basis. However, this will not happen in the absence of technological advances that allow practical economical movement to carbon-free electricity in countries such as China and India. For that to happen rapidly requires concerted, high-priority technology cooperation. The notion that humanity can escape to Mars is nonsense. Either we learn to work together, preserving our remarkable home planet, or we sink to the abyss together. China and India are not the only big emitters. There's also the United States, which has withdrawn from the Paris Agreement and says that climate change is a hoax. Nevertheless, there is a basis for optimism. The United States is still a nation of laws. 21 young people, including my oldest grandchild, and I have filed a lawsuit against the federal government demanding a national plan to phase down emissions rapidly. I expect that we will win this case even with the conservative Supreme Court, because our case is based on the most fundamental constitutional principles. Young people are being deprived of life, liberty, and property without due process of law, and they are not receiving equal protection of the law. It is analogous to the case of civil rights in the 20th century. But the courts cannot write laws, so it is important to also influence the legislative branch. Good progress is being made in the U.S. by a rapidly growing organization, Citizens Climate Lobby, which has carbon fee and dividend as its objective. CCL uses a democratic process. It visits Washington, speaking to congresspeople and their staffers about fee and dividend. They also write op-eds and letters to the editor. Joining this organization is probably the single most important thing a citizen can do to address climate change. There are CCL branches in India, but not in China or Taiwan, so that's something to think about. Thank you.
Thank you very much, Dr. Hansen, for this very inspiring talk. Our next talk will be given by Professor Ramanathan. I'll give a brief introduction. Professor Ramanathan was born in India and educated in India and did his graduate study in the United States. He received his PhD in 1974 from Stony Brook, the State University of New York. He, in his career, he made similar contributions in our understanding of how non-CO2 greenhouse gases, such as CFC, as well as aerosols, such as atmospheric black carbon, and how these affect climate change. He also helped to create, under United Nations, UNEP, the Climate and Clean Air Coalition to reduce short-lived climate pollutants. He started also a project called Project Surya to mitigate soot emission from solid biomass cooking in South Asia as well as in Africa. In him, we see another scientist in action indeed, Professor Ramanathan.
Thank you so much for the kind introduction. Again, it's really a great honor for me. Dr. Hansen talked about extreme weather, so I'm going to pick up that theme. The science of weather extremes and its relationship to climate change has improved so tremendously just in the last 5 years. The normally cautious American Meteorological Society came with a statement last November. We are experiencing new extremes because we have made a new climate. If there was any doubt, we should all be certain that the climate we are living in is new. It's not the climate we inherited. And because of the focus on the weather extremes and its linkage with climate change, there is a new science of health impacts of these extremes. And this was done by WHO and Lancet. So we teamed up at the Pontifical Academy of Science. Professor Lee was also involved in this, just last November. And this was medical experts, scientists, economists, etc. And we came with the statement that with unchecked climate change and air pollution, the very fabric of life on Earth, including that of humans, is at grave risk. This statement was subsequently signed by Stephen Hawking, who passed away, as you know. He sent me a personal note saying that he will do what he can to help issue of climate change. Of course, I've got Governor Jerry Brown, several Nobel laureates, and 14+ mayors. So clearly, now that we all agree the weather extremes are linked to climate change, we have to have an intense focus on the climate impact, the health impacts. So we then published this in Foreign Affairs. This is a journal read by most policymakers and diplomats. So we said the evidence is mounting that climate change will have an extreme impact on human health in the near future. I'm going to help define what that near future is. And there was a statement, we can have widespread impacts on mental health. So I was trained as an atmospheric physics. What am I doing talking about health effects and mental effects, right? So I need to take you through that journey, how I came to this situation. So my journey started in this village in South India. This is just next to my grandfather's house where I spent a lot of my summers. His house was washed away. So I took this picture in 2004. The only place to sit is not inside the house, it's hot, and not outside, it's hotter. The only place is the veranda. I have sat on that veranda summer after summer, blissfully happy like these kids. So why did that topless kid come to the US? This was my single-minded dream, to buy a Chevy Impala and travel around the US. I was just 24, what do I know? But what happened to my Impala dream? I landed in the hands of Pope Francis. So how did that happen? That affiliation with the church just changed my life. I said, I cannot just do the science, I have to look at the solutions. So I'm going to do a deep dive into the science and then do another deep dive into the solutions part. Dr. Hansen already introduced this. So the planet, just a cartoon, basic energy source is sunlight. Not all of that sunlight goes into the absorbed by the planet. It's reflected back to space by clouds, houses, streets, oceans, everything. So that 70% heats the surface of the planet. Then it gives off that energy as heat radiation or infrared, okay, till 70% goes out. But what does the intervening atmosphere do? The atmosphere, mainly gases, water vapor, and CO2, acts like a blanket, just like a blanket on a cold winter night traps your body heat and keeps you warmer. It traps the infrared, and so makes it harder for the energy to escape. So the ground has to get a lot more hotter to get rid of that 70%. So, I did my PhD on the greenhouse effect of carbon dioxide in Mars and Venus. Both are, mainly CO2 atmospheres. So my first thing when I jumped, I was at NASA then as a postdoc, and I was so lucky. At that time, NASA was about getting ready to launch, thinking of a climate satellite. So I joined that team. My first interest was, I want to measure the thickness of that blanket, okay? So we had in the satellite infrared radiometers, scanning infrared radiometers, so we can look through clouds or in between clouds. We measured the incident sunlight. It's a first calibrated measurement of the solar irradiance. All the energy budget components were measured. So how did I determine the thickness of the greenhouse blanket? Let me see if I can show the light here. Yeah. So we would take the scanning radiometer, look at the sky in between the clouds, and measure the radiation coming through the atmosphere in the clear skies. After 2 years of averaging, that was the energy escaping to space. So then the question is, how much was the surface radiating? We had measurements of surface temperatures, both in situ and satellite measurements. So we found that the surface was radiating close to 400. By the way, the units watts per square meter is watts, the same as the energy, like you say, 60-watt light bulb, square meter to square meter of the Earth's surface. So the difference between the two gave us the direct thickness of background water vapor and CO2 and others. Now we can compare that, how our activities have thickened that blanket. So that's the way I see it. We have made that blanket thicker. And the United Nations report says, as of 2010, that blanket has become thicker by 3 watts per meter squared. So we have basically increased the thickness of the blanket by about 2%. And Dr. Hansen already beautifully described what that energy means in terms of nuclear bomb. So what's contributing to that thickness? What human activities? So as of 2010, this is how many tons of CO2 we have emitted. 2 trillion tons. That's 2,000 billion tons. About 46% is still up there. About 930 billion tons in this thin shell. Just imagine the weight of that. That's equivalent to 450 billion cars circling the planet, okay? And then, of course, we are emitting about 38 billion tons every year. So this was our understanding as of 1975. CO2 was the main greenhouse gas. That's when I was a postdoc. My knowledge was of Mars and Venus. I had not that much understanding of the literature. And that year, 1974, when I became a postdoc, is when Roland and Molina, who got the Nobel Prize for this, came with the suggestion, chlorofluorocarbons, these were called freons, CF11 and CF12, were destroying the ozone layer. That was a year before. And I started looking into the greenhouse effect of this CFCs for reasons I can't get into now. And what I found were these were really super greenhouse gases, CFC 11 and 12. So what do I mean by that? So I need to take you a little bit into the infrared physics, why they're so potent. The potency of them is such that a ton of the CFC 11 and CFC 12 had the same greenhouse effect as 10,000 tons of CO2. Why is that? So now let's peel this layer a little bit more. Remember I said the blanket thickness? That's all in the infrared. So I'm showing as a function of wavelength in the infrared. That is how, this was the data collected right over the Pacific Ocean. That is what the ocean was radiating to ventilate its heat to space. What was measured was these wiggly guys. So the black shaded layer is the thickness of the blanket. Okay, you can see that is where carbon dioxide is trapping the planet's heat. And these being water vapor. Why is CO2 just here and not here? It's due to the quantum mechanics of carbon dioxide molecule. And the planet was nearly transparent in these wavelengths, 8 to 12. You see how thin the blanket is? That's the only wavelength the planet has to ventilate its heat to space. And miraculously, the quantum mechanics of CFC was such that they were absorbing in this window. They're just shutting off in that where the heat could escape. So that's one of 3 or 4 reasons why they were so potent. This then opened a Pandora's box. Many groups added more gases. In fact, Dr. Hansen's group had a paper a year after that pointing out other greenhouse gases. So now we sort of have a good idea all the pollutants that are warming the climate. There was one more issue to be sorted out. It was around the 1980s, models were suggesting there's this black carbon, soot, basically the black smoke you see from diesel and your cooking fires. And they were contributing to warming. They are not green, they're not gases, they are particles, they're not greenhouse pollutants, but they were absorbing sunlight directly. It's the most, per ton of this black carbon, it's the most potent trapper of sunlight. So we wanted to quantify this. So Paul Crutzen and I, we proposed an experiment that we will go to the Indian Ocean. During the wintertime, you see massive amount of air carrying all the pollution by more than 1.5 billion, and it's transporting over the northern Indian Ocean. So we thought we take a simple ship, boat, put our instruments and go north and south, because once you are here, you are seeing air from Antarctic, clean air. So we thought it's a perfect experiment. But what started as one boat ended up in 6 aircraft. Over 20 nations joined this experiment, including India. And Europeans moved a satellite, so we have full coverage. So what we were shocked to see is this massive amount, river of pollution, okay? And we had aircraft measurements to really precisely pin down the chemical composition. I'm not going to go through all this, mainly let me focus on the black carbon. The black carbon was only about 10%. Yet it was the most dominant effect on this radiative heating of the planet, and we wanted to measure this directly. How do you measure this? So in my lab, I designed small UAVs, wingtip to wingtip. It's about 3 meters. We squeezed about 14 to 15 instruments in this. The top UAV would measure how much sunlight was coming in, how much was going out, and the bottom would measure how much was transmitted. And this middle guy would go up and down to sample what exactly was there. Using that, we were able to pin down the solar heating by black carbon, okay? And then we also were able to show this black carbon over the Himalayas is part of the reason, but the other groups had shown the way the glaciers are melting. So finally, we know how we are warming the planet. Carbon dioxide, the surface area depicts how much heating, the thickness of the blanket. And these were the non-CO2 trace gas. I talked about CFCs. They were replaced by HFC, hydrofluorocarbons, nitrous oxide from fertilizer, ozone. We don't emit ozone, but we produce ozone by these pollutants. That's methane, and this is black carbon. Okay? So now we know how much heat we have added and how we did that. So the next thing is, how does the system respond? So the planet begins to warm, and then it starts a chain of feedbacks. The most dominant one is the feedback due to water vapor. Sorry, I think, yeah, let me take a digression. So these pollutants, non-CO2, are called super pollutants because they're at least an order of magnitude more potent than CO2 per ton of these emissions. So there are two types. One is short-lived. Their lifetime is less than 15 years compared to a carbon dioxide molecule in centuries to millennia. And there are long-lived, which is nitrous oxide. When you add them all up and use the IPCC estimate, they contribute about 50% plus or minus 10 to the heating of the planet. Okay? Keep that in track. It plays an important way into the solutions. So let's talk about the water vapor feedback, right? The first thing you heat the ocean, it starts evaporating more water vapor and makes the air humid. And we heard that from Dr. Hansen too. So what governs that? This equation, by the way, pretty much can tell you the whole story about why storms are intensifying, why droughts are intensifying. It's not the only one, but it's a dominant equation. It says the vapor pressure, how much water in the air, increases exponentially with the temperature. So when you differentiate this, and I'm not going to go through the math, what it tells you, for each degree rise in temperature near the surface, water vapor will increase by 6%. And remember, water vapor is the most potent greenhouse gas. So I wanted to quantify this. So first we said, is really atmospheric water vapor behaving like that equation? So this is the microwave satellite data, monthly average. We were shocked to see how closely the water vapor distribution, mind you, this is taken all over the planet, follows this Clausius-Clapeyron law. Instead of 0.406, it's about 0.055. Okay? Now the question is the blanket thickening? So that is the satellite data for the radiation budget experiment. We calculated the thickness of the blanket from the satellite data, and you see clearly the dominant thickness of the blanket is in the tropics where the ocean is warm, and it almost decreases by a factor of 4 as you go to the pole. So every year, the whole planet warms and cools. In July, it's the hottest because the northern hemisphere dominates it. So we thought, is the greenhouse effect of the atmosphere increasing with temperature? I have never seen a data confirm something like this. You can see the slope. And the magnitude of that, the rate at which the blanket thickens with temperature, was within 5 to 10% of what models like Dr. Hansen and others had published. Okay, and without this water vapor feedback, the warming would be half as small. Honestly, I don't think climate change would be that serious a problem yet. Okay, so this is a spectacular confirmation of, originally it was proposed by Svante Arrhenius in 1895. So that's one. Now let me go to the other feedback. We know as you warm the planet, the glaciers would melt. Ice in the ocean is melting. In fact, my wife and I took a cruise to Alaska to see the sea ice before they disappear. So we wanted to see, the theory was, right, this was proposed by Budiko, a Russian meteorologist, that you see how when the lack of snow, the surface is dark. The snow surface reflects about 50 to 80% of the sunlight back to space. That's what keeps the polar region, as the cooler it is. Once you expose that, you are talking about a quantum increase in sunlight absorption. Same thing in the ocean. So this was a thesis work of one of my students, as 4 years ago. So this was the sea ice distribution in 1979. And in 2002, most of the sea ice is blown away, but 40% in the September. And the satellite data showed the planet is getting darker because it's absorbing more sunlight. And this is, again, the Earth radiation budget experiment data. This is the albedo, that is, from the sky satellite, you see how bright the Arctic is. It has gotten darker. It was deflecting 38% of the sunlight. Now it's reflecting only 32. Enormous amount of positive feedback. Okay? Here, the magnitude V got was about 2 times larger than what the models were predicting. So that is how the warming gets amplified, feedbacks. I'm just talking about 2. I want to move on to other things. So we clearly understand how we are heating the planet, and we clearly understand how the planet is responding to that heating. And while I'm just showing you my work, there's tremendous amount of work in the literature on this, okay? So now let's move on to, we think we are reasonably confident about the theory. So how do you test a scientific theory? You make a prediction with it. So I teamed up with a meteorologist in 1980. We did a statistical dynamical model to see when will we see the climate signal from the weather noise. And we concluded the warming has to appear, should be detectable before 2000. Otherwise, we know that theory is something flawed or we don't understand the heating. And here I'm showing the globally average surface temperature distribution. And you can see that this is from 1860s. You know, in this unit, it's about minus 0.6, and the planet has steadily warmed. We published this paper in 1980 when the planet was still on the cooling or in a sort of a limbo, right? And it was in 2000 when IPCC concluded they are seeing a statistically significant warming. So you can ask a question, wait a minute, why do you have to wait till 2006, 2000? The planet is already warming. You can't say this warming for a single year. You have to average it. So you needed at least 10 years of data from 2000 to 1990 to say that the signal is much larger than the noise. Okay? So I want to move on to, hopefully I persuaded you, the science Dr. Hansen discussed and I discussed, we are on sound basis. So using that, let's make a prediction. Remember, I said we already added 2 trillion tons. That's enough to take the planet to 1.5 degrees in 10 years. Some are now saying it could happen in 7 or 8 years for a particular reason. So the 1.5 degrees is almost baked in unless we find a magical way to suck that CO2 out of the air. Okay? There's no technique I know which is scalable. But the problem is that by the time you go to 2030, when that warming shows up, you would have added the 3rd trillion ton, which would take you to beyond 2 degrees by 2050. Okay? So I want to tell you, again, focusing on the health, what are the health experts saying? What would the 2-degree warming planet do? These are basically, I'm summarizing publications, none of them are mine. 1.5 billion exposed to deadly heat. They came with a clinical description of what deadly heat is. Okay? And 600 million would be exposed to vector-borne disease because these vectors like mosquitoes would travel to warmer climate northwards, and widespread droughts. And this is mainly a mass displacement and migration. I don't know how many of you know, every year due to weather extremes, about 20 million people are displaced. When they're within their country, national boundaries, it's called displacement. When they move outside, then it's called migration, okay? That is just a 50% probability. Because of our feedbacks and nonlinear amplification, there is a 5% probability it could shoot to 3 degrees by 2050. So now let's move on, all right? I've wrapped the science part of it. I want to go to the solutions. There are 3 singular events which happened to me, which made me change from shift to the solutions part. First is, we discovered in the Indian Ocean experiment, when I say we, I'm talking on behalf of 200 scientists, that a third of the black carbon was coming from cooking indoors with firewood. I could relate to that. That is exactly, almost identical to the kitchen of my grandmother. I have sat where that cat is, and she would feed me hot food. So I could relate to this cooking issue. And I thought, this is a solvable problem, right? I mean, just giving clean cooking. The second thing was, I was admitted to the Pontifical Academy of Science by Pope Benedict. So I mean, normally, when you're elected to the academy, they personally, the Pope personally elects you. There's a chain he puts, you can see on arm, my shoulder. And Pope John Paul II asked me, Indish. So I wanted to say, yes, I was Indian, but no, I'm an American. But that didn't get properly transferred in Polish. So he started asking me about India. But somehow I realized this is a teaching moment for me, okay? And the third is, 4 years ago, our President Janet Napolitano, she is a remarkable person. She was the Homeland Security chief under Obama. She declared the whole 10 campuses would become carbon neutral in another 10 years. So she asked me to lead 50 faculty from all 10 campuses to come up with, think about solutions. So we released this report called 10 Solutions, okay? Remember, this team of 50 had physical scientists, social scientists, humanities, even experts in faith, but mainly technology. So we put the solutions under 6 clusters. One is the science pathway, okay? And so there are 4 ways, there are 4 levers we have to bring the climate change. The first lever, of course, has to be carbon neutrality. If we don't do that, we are just wasting our time with the other things, okay? And that will give you a degree and a half cooling in about 40 years. The second is energy efficiency, all right? There's still a long way to go in energy efficiency. And I tell you, between the two, the low-hanging fruit is we are throwing away 30 to 40% of the food every year. Western societies is 40%, developing 30%. That alone would give you several gigatons every year. Just stop throwing food away. So this is the super pollutants, I'll come to that. And this is atmospheric carbon extraction. So we have 4 levers. Because of the delay in actions, you don't deploy any one of these 4, there's no chance you have to keep the warming under 2. Okay? And the second one, which rose to the top, is societal transformation. And that's where I started working on. I'm going to give you some example of that. Governance, right? When people say, I'm going to cut down emission, how do you ascertain it? You have monitoring, you have governance. And the second is market and regulation. These are economists from Berkeley who proposed this: cap and trade, carbon tax, carbon dividend, and simple market incentives. The next one is technology measures. This is what the deep decarbonization, carbon extraction, cutting the super pollutants. So I want to just now tell you my bias and my focus. I'm not thinking about 2100. I'm focused in the next 30 years because I'm thinking of the 3 billion people who had nothing to do with this. Their carbon footprint was just 5%. We know when you have extreme droughts and heat waves, they're going to get wiped out. So my focus is, can we do something to keep that warming at 1.5, at least next 30 years, okay? So this is pulling the carbon lever, and you see that it takes about, we started it around 2012, 20, it takes about 30 years, 40 years before it starts kicking in, bending that curve. So that's the no action, business as usual. When you cut these super pollutants, because their lifetime, black carbon is 1 week, it's gone in a few weeks if you stop its emission. Methane is about 10 years. That curve starts bending right away. So you have a fighting chance, at least up to 2050, with the super pollutant lever, to keep it close to 1.5. But you see afterwards, it loses its steam, its CO2 kicks in. So think of it as a relay race. The starter is the super pollutants. So he carries the baton until 2040 and hands it over to the CO2. That doesn't mean you can wait till 2040 to do the CO2. You've got to start all of them right away. And then you see but this is a 50% probability. If you ask me to give 95% probability, this will be from here to here. So we have taken a gamble, all right? So, let me see. Yeah. Sorry, let me point out. What's the difference to the people living in 2050? I can safely say I'm not going to be around. So what do you say? How many do you protect instead of shooting past 2 to keep it close to 1.5? This was again about 10 papers have focused on this. There's going to be, I think, a sensational report released next week on this topic. It turns out between 2 to 1.5, you can exposure reduced by 1.7 billion people to extreme heat. And the heavy precipitation, they estimate, could be reduced by 1/3. That is, if the heavy precipitation of 2 degrees is this much, that could be reduced by 1/3. And same thing, droughts, more than 250 million people could be saved from exposure to drought. So there is a huge gain in keeping it at 1.5 degrees. So the super pollutant idea has gotten hold. Now there are 2 efforts, the Climate and Clean Air Coalition by United Nations Environment Program. There is a remarkable Swedish head of this, Helen Valdez. She has recruited 16 national partners and 17 non-state partners. They have developed 15 solutions, measures to cut down black carbon, to cut down methane. It's being implemented in places like Mexico, Nigeria. And California, our Governor Jerry Brown passed a law. It's by the Senator Laurate. And his respect for science and scientists so much. When we were I was sitting in the audience, and he suddenly called me, he said, "Ram, you introduce us." So I had the honor of introducing this bill, which will cut down in California black carbon by 80%. This is from diesel. It's such a simple solution. It's the diesel particulate filters. Okay? Of course, it costs. When I say simple, the technology is there. And then we're going to cut the methane emissions simply by taking the farm manure, right, and capturing the methane and burning it for fuel. And you release CO2, but the methane is 25 to 90 times more potent. And the HFCs, we're going to go to HFC free. But this is also passed by UN. So I want to go to now the societal transformation. Our 50 California document concluded, without societal transformation, you have less chance of solving the climate change problem. So the first one here is the cook stoves. I was so fortunate, after 2-3 years, my daughter Nitya, who is not here, she started an NGO. She's a wireless technologist. See, this is a 100-year-old problem. Harvard, Princeton, MIT, they've been trying to solve this. And it never worked, because we don't know if they were relying on survey. So Nitya put a sensor in each of the stove, and she persuaded her sister, Tara, who is here, to do this field experiment in the field to document over 5,000 stoves that were instrumented. We have a much better understanding why these women are not using these stoves, and then how to fix that problem. The second societal transformation you see, we want to educate 1 million climate warriors to fight the climate problem. We think that's the scale we need. When we say climate warriors, we are talking about undergraduate students and others, young people. So we have created this course, okay? And this is launched in 7 campuses in the UC system. And now we are negotiating with university in Omaha, Nebraska, Creighton University, and 2 universities in Texas. And Stockholm is partnering with UC to take it to Europe. And I'm excited to say the National Taiwan University is now taking it up. So we're going to have discussions between UC and National Taiwan University. What this course focuses on solutions. The first lecture, I give the depressing part of it about climate change. Then the solution experts take over. And how do we expect to go to 1 million people? There are 4 components. One is the course, and then we are creating a digital book on the solutions. And the third is we are creating an online version. What does that mean? A professor sitting in National Taiwan University can teach all the students in Taiwan, provided the universities give them credit for it, okay? And the fourth is we are partnering with Coursera to convert it into a MOOC course. The next is that many of us in the Pontifical Academy are pushing for an alliance between science, religion, and policy. This is the summit. I worked with the Academy on bringing all the mayors, and you can see our governor here. So this was a meeting we held in 2014, and it was titled Sustainable Humanity, Sustainable Nature, Our Responsibility. At the end of it, all the attendees, remember this Pontifical Academy has about 25 Nobel laureates in all areas, physics, chemistry, biology, and scientists from all disciplines. So this academy, we came to this conclusion, finding the ways to develop a sustainable relationship with our planet requires ultimately also a moral revolution. Jim Hansen talked about the moral issue, handing our children a damaged planet. I'm also focused, that's intergenerational equity. I'm focusing also on the intragenerational equity. There are these 3 billion people who have still not discovered fossil fuels, but they are suffering the worst consequences of our fossil fuel consumption, okay? And I'm telling you, I started giving lectures in churches, and I see nothing but receptive audience. And I'm just not giving my lectures in the safe zone of San Diego, which is a liberal city. This is a lecture I gave in Omaha, Nebraska, invited by a Catholic institution. February, the temperature was 20 degrees outside. 750 people showed up. And many of them came from the rural areas, and their statement to me was, Professor Ram, we didn't know climate change had so much science in it. And because of all this, I'm sort of extremely happy to tell you the president of the American Evangelical Association, which oversees 30,000 churches, Reverend Leith Anderson, came to our meeting on climate change at the Vatican. Apparently the first time an evangelical leader has gone to a Catholic thing. Again, I don't want to mislead. I'm not thinking this is all going to solve the problem. Just to those of you, individual efforts could make a huge impact. Each one of us can do something about this. So finally, to implement all the 10 solutions, most academics in California have gotten together. So we have formed this coalition called California Collaborative for Climate Change Solutions. And we have institutions like Caltech, all 10 campuses of the UC, Berkeley, Irvine, Stanford, University of Southern California, 20 campuses of the state system. So what are we planning to do? Take the innovations at the bench level, do demonstration projects on the scale of about 50,000 population. We will take only those solutions which have a potential of at least taking out 1 gigaton of carbon, okay? And then find out which of these solutions would work and then scale them up, bringing in commercial partners. We are already in discussion with a lot of industries, including the energy and oil industry. So, just the moral of the story is that the situation has come to such a state, we cannot just wait for top-down efforts. They are critical, don't get me wrong. But till the national leaders figure out the urgency of the issue, each one of us, we have to do what we can to keep that candle burning till the nations come to sensus on this issue. So my motto, I want to leave with you this, and it's basically, knowing is not enough, you must apply. Willing is not enough, you must do. I wish I had thought of it, but the German philosopher Goethe is the one who said it. Thank you.
Well, I think really had the privilege to hear two prominent scientists to show how they have applied their knowledge, their scientific findings to solve this particular problem, to fight the battle for achieving how to bend the curve, bending the curve. Let's thank Professor Hansen and Ramanathan for their wonderful speeches. Thank you.
Thank you very much, Dr. Liu, for hosting this session for us. Thank you. And thank you again to our laureates, Dr. Hansen and Dr. Ramanathan, for your inspiring lectures. Ladies and gentlemen, this is the end of the Sustainable Development Lecture. Thank you very much for your participation today. If you have any questions regarding the lectures, you're welcome to join the press conference on the first floor. 各位来宾，第3届唐奖人得奖人演讲永续发展场到此圆满结束，非常感谢您今天的参与。如果您希望针对演讲的内容提问，请移驾到1楼的前瞻厅。离场的时候，也请记得您随身携带的物品，并归还您所借取的同步口译接收器，取回您的证件。稍后我们的场内将进行清场，有报名下一场的来宾，请在场外重新报到。谢谢您的配合。
make the award announcement of the 2016 Tang Prize in Sustainable Development. Please join me in welcoming Dr. Lee.
I'm now honored to announce the recipient of the 2016 Tang Prize in Sustainable Development, Arthur H. Nordenfeld.
Ladies and gentlemen, the lecture will begin shortly. Please take your seats. Please remember to set your mobile phones to silent mode. The lecture today will be conducted in English and Japanese. If you need interpretation service, interpretation headsets are provided outside the auditorium. Channel 1 is Chinese and Channel 2 is English. 各位来宾，唐奖得奖人演讲汉学场即将开始，请您尽速入座。今天的演讲将全程以英文和日文进行，聆听中文翻译内容，请将同步口译接收器频道切换至1。最后，请您务必将手机调整为静音模式，谢谢。Ladies and gentlemen, please give a warm welcome to the laureate of the 2018 Tang Prize in Sinology, Dr. Stephen Owen. And please welcome Dr. Yoshinobu Shiba. Please welcome our host, Dr. David Wang. Good afternoon, distinguished guests, ladies and gentlemen. Welcome to join us at the Laureate Lecture for the 2018 Tang Prize in Sinology. To begin with, we would like to invite to the stage the host of this lecture, Dr. David Wang, academician of Academia Sinica, to give us the introduction. Ladies and gentlemen, please give a warm welcome to Dr. Wang.
Thank you very much. Good afternoon, ladies and gentlemen. This is truly a great honor and a pleasure for me to introduce two most distinguished scholars in the field of sinology. They are also the recipients of the 2018 Tang Prize in the field of sinology. Professor Steve Owen and Professor Yoshinobu Shiba. They each represented the highest standard of excellence in their respective field of concentration. For Professor Owen, classical Chinese literature, particularly in the field of poetry and poetics. Professor Shiba, pre-modern socio-economic history, particularly with a concentration on Song Dynasty commerce and societal dynamics. Their work, their dedication, their insight, and their impact have inspired many young scholars already, and I believe many of us here have read their works and admire their scholarship. Today, they are going to give lectures on new topics, which I'm sure will be extremely illuminating and inspiring. And definitely, this is a great opportunity for us to listen to their talks and share their wisdom with us. 各位女士、各位先生，这是一个非常难得的机会。在2018年的汉学奖，我们请来2位大师，美国的宇文所安教授以及日本的斯波义信教授。宇文所安教授的成就是在古典中国文学，尤其是唐代的诗歌以及诗学。斯波教授的专长是宋代的社会史和经济史，但是他们2个人各自的专长都延伸到其他的领域，他们的治学的精神。他们对于学问的向往以及专注，数十年如一日。在今天，我们很难得的有机会在场聆听他们在得奖之后的第一次的演讲， 各自带来新颖的题目，我想我们一定能够从他们的演讲中得到新的启发以及体会。So I would like to first to introduce Professor Steve Owen, and he's going to talk about something extremely interesting. And I just got this topic. The topic is Meaning in Literature, the Bamboo in the Breast and the Bamboo in the Belly. 文学里面的意识，胸中之竹与腹中之竹。I'm particularly honored to introduce Professor Owen because he is my colleague at Harvard University. This is great to be reunited with Steve here in Taipei. Steve, 现在我们有请宇文所安教授，那么发表他的演讲，谢谢。
Okay. Thank you. Thank you for inviting me. I find myself here. I had to find a topic, and I wanted the topic sort of came out of the award. Since this was an award for sinology, I wondered what we mean by sinology. It was clearly not the idea of sinology I knew when I was a graduate student. It's now paired with Hanxue, which I always thought of in its Japanese pronunciation as kangaku. I don't know what it is. I learned from the people introducing the Tang Prize that it's supposed to be a very broad term, encompassing many fields, but not thinking of them as a unity. And I had to put this up. So I did what we all do. I looked on the web and Wikipedia to find out what sinology was, or Hanxue was. It turns out that it is only for foreigners. Oh my goodness. But it's interesting because this includes a negative. You see, you wonder what's not sinology. And you learn that what's not sinology is guoxue. Because, of course, I can't do guoxue, because it's 不是我的国家. So I can't possibly do guoxue. Can this possibly be intellectually interesting? And I think actually it can be. Guoxue, of course, includes all non-Chinese. I wonder who it does, does it include people who were born in Singapore or Malaysia? And all these problems arise in my head, if they can do guoxue or not. And it claims to understand from the inside. Hanxue, on the other hand, includes foreigners and looks from the outside. Now, I'm sorry to say to the guoxue people, I don't believe anybody in the 21st century is still looking at 12th century literature from the inside, unless they're very, very, very old. And I don't think they're that old. I worry about that, those people. But literature is very good at giving life to ideas. We literature scholars like to work from texts, through texts, and I have a great one, I think, trying to think about what's guoxue and what's Hanxue. A great text by Soot. This seems to offer a section for the guoxue scholars and a section for the Hanxue scholars. Different modes of knowledge in literature, and the two actually may need each other. You may not be able to have good guoxue without Hanxue. You may not be able to have good Hanxue without guoxue. The first one, guoxue, sounds very Chinese, the first part. It gives you a chengyu. Sheng you chengzhu. Oh, we love stories, texts that give us a chengyu. The other is very, very smart, with deep insight into the world of the Song dynasty. And it's something that doesn't have a precedent anywhere. Okay. Now I've got to find where I'm going here because I've got to go on to my text. The text, and this is the famous text for his old friend Huan Tong, who had passed away that same year in 1079. And in autumn, Su Shi is airing his paintings. You know, in autumn you have to take your paintings out and hang them up so they dry and don't get bugs in them over the winter. And he starts thinking about this text, this painting, right? And the text involves two moments. The first one is one in which Huan Tong speaks to Su Dongpo as a master, that is, Huan Tong is the master. He himself is, you know, someone who is himself in change, but someone who imparts a lesson that only a master can impart. He's not going to change his mind tomorrow. Somebody who already knows. The second moment, Huan Tong is a person in change. He has no control over his life. He's not a master of anything. He's helpless in face of the world he's in. And to see these two Huan Tongs together is, I think, an interesting moment. Probably only Su Dongpo could have written this essay. People of his own time and people now recognize he was the genius of his age. But even though only Su Dongpo could have written it, the writing is successful only because everybody who read it in the Song Dynasty understood, especially the second part, what was true of it. It made assumptions that people all understood. They knew all those nice things you say about painting are not really true, that the world is messier than that. On this level, we're not just talking about individual genius, but in shared understanding that occurs in a single age. The significance of the second part does not lie in the surface claim, but rather in what you have to know to read the text, or you have to take for granted to read the text. I'm talking about different kinds of knowledge, right? One makes an intellectual claim, and the other presumes that you understand something in a rather different way. As I said, we start with the time, 1079. The process, he comes across, in the process of airing his paintings, he comes across a painting of bamboo done by Huan Tong, one of his dearest friends who just died earlier that year. And the prose essay is called An Account of Huan Tong's Painting on the recumbent bamboo in Yundang Valley. It starts with a grand claim, which you see, read the first part here. Intellectual historians always, and art historians always focus on the first part. They do not read the second part. Why should it? The second part is all jokes. The first part is serious. It's what Guo Xue wants. Right? The second part is silly. But somehow, if you read a text that starts with bamboo in the breast and end up in the end with somebody spitting bamboo shoots out on a table, you know that that other part, the bamboo in the belly, goes along with the bamboo in the breast, and you have to figure out what to do with the bamboo in the belly. Right? Now, here the opening goes. When the bamboo is first born, it's just a sprout of an inch, yet the segments and leaves are complete in it. Going from a cicada or a snake molting to reach up 10 yards, like a sword held upright, is something that it has from birth. Nowadays, painters do it segment by segment, burden it with leaf after leaf. How can this still be a bamboo? Now, Su Dongpo invokes neither the ideal of a fully grown bamboo nor the mimesis of any actual bamboo in the world. This is not about an idea of bamboo or a picture of bamboo you're looking at. This is bamboo as an organism that grows. And I don't know how to paint a growing organism. That's a very strange power, right? The bamboo, all the parts are complete in the beginning of the bamboo, but it has the propensity to grow and extend. Please forgive me if I think of the bamboo as capital. You know, you have a certain amount of money and you invest it and it keeps growing and growing and growing. This is actually very important for the last part of the thing. The bamboo is 1 inch in, and we all know that the mind is fangsuan, right? The mind is, so the bamboo fits, the baby bamboo fits exactly in the mind. Hard to miss that. It has the propensity to grow beyond the mind out onto paper or silk, or to grow out into the world, or maybe into a lot of money. We'll talk about that. It's easy to paint the static bamboo or any particular bamboo in the world. It's hard to paint an organism. And we go on with the famous simile of the act of painting. I use Michael Fuller's translation, which I will give not here, but I'll give you the original text. Thus, to paint bamboo, one must first obtain a complete one in one's breast. There's your chengyu, right? We all love our chengyu. One grasps the brush and looks thoroughly. Then, when one has seen what one wants to paint, one rises rapidly to follow it, moving the brush in direct pursuit to close upon what one has seen. It's like a rabbit starting as a hawk dives. A little looseness of concentration and the rabbit gets away. This is what Wan Tong told me. Although I knew the nature of bamboo, I could not convey it to paper. Now, when one knows an object's nature but cannot achieve it, the true effect, inner and outer, are not one. The mind and the hand are not mutually responsive. This is the result of not studying. If one is not well practiced in grasping whatever one has noted within, what one ordinarily fully comprehends will suddenly be lost at the crucial moment. That is, Wan Tong told me how to paint bamboo. I understand he's right. I just can't do it. We'll see later that it's problematic. It's a striking passage, and it illustrates the 11th century interest in spontaneity, or Fuller's better word, immediacy, things you do just spontaneously. It's an easy, comfortable argument, predictable profundity. Indeed, the majority of those who comment on the piece go no further than this passage. It is serious, or at least pretends to be. Much of the rest of the essay, as I said, consists of jokes added to it. Now, the disposition of a literary scholar is to notice precisely those texts with peculiar links and homologies. And as I said, when you have bamboo in the breast and bamboo being spit out on the table, you just try to figure, how does that work? We know when we read that Su Dong-po is playing. And I'll tell you something, I know Su Dong-po well enough to know that when he's playing, he's trying to deal with a very, very difficult problem. He doesn't play otherwise. Now, there's something wrong here with the authoritative lesson, offering a reflective knowledge of mastery that's not characteristic for Wan Tong and the rest of the essay. There's something wrong with the lesson that Su Dong-po can understand but not himself do it. This suggests Will Lun Bien, Will Write Bien, who knows how to make a wheel but can't teach anybody. And that's actually used later on, the metaphor of Will Lun Bien. So Su Dong-po can understand, but he can't do it. It troubles me that bamboo is an organic growing thing, but that Wan Tong uses a hunting metaphor. This may remind us of Wan Tong's roasted bamboo shoots, but it also recalls one of the most famous passages in Zhuangzi, the end of Wai Wu. Everyone knows most of this passage. Let's see if I can get to the next passage. Oh, yeah. So you all know this, right? The fish trap exists because of the fish. Once you've gotten the fish, you can forget the trap. The rabbit snare exists because of the rabbit. Once you've gotten the rabbit, you can forget the snare. Words exist because of the meaning. Once you've gotten the meaning, you can forget the words. Everyone takes this seriously. I'm not sure Zhuangzi took it seriously, because you see the most famous, conclusion to that, which is, where can I find a man who's forgotten words so that I can have a word with him? So that while the first part tries to say, get the meaning and shut up, Zhuangzi says, keep talking. This is very common in Zhuangzi, where he says something and then unsays it at the end. It's not difficult. It's very simple Chinese, quite clear. Yet it's consistently overlooked, except for the attempt to explain it, which just doesn't deal with the real thing. And Zhuangzi often used figures of death and deadliness, traps, snares, for the loss of naturalness, not for good things, right? Killing and consuming, leaving things in silence. But Zhuangzi always repopulates the silence with laughter. The question is, how do we know what an author is teasing us? Is Zhuangzi teasing us? Is Su Dongpo teasing us? I don't know. What do we do with a text that begins with an image of organic growth, then shifts suddenly to an image of hunting and killing? Well, we look for clues if something is wrong. Su Dongpo goes on to quote his younger brother, who wrote a fu on Wentong's ink painting. Let me just get to that one. Oh, yes. My brother, Su Che, wrote a poetic exposition on ink painting of bamboo and sent it to Wentong. It said, Butcher Ding was someone who cut apart oxen. Yet those who would nurture life learned something from him. Wheelwright Bien was someone who cut wheels. Yet the one who was reading agreed with him. You, sir, have invested such an idea in these bamboo. Yet would anyone disagree if I think you possess the way? Ziyo never practiced painting. There's his brother Ziyo, Su Che. He simply got the idea. As for myself, I didn't just get the idea, says Su Shi, Su Dongpo. I got the method for painting. Now, if you know Chinese, you know this is wrong. You're supposed to say, he just got the method for painting. I got the way. So when Su Shi turns that around and says, we both got the way, but I got the method for painting. And he can't, of course, did he get the method for painting? He tells us himself he can't do it. Just the method. Okay, at this point we should realize that this is a hopeless muddle. And the source of the muddle is the paradox of intuitive immediacy of spontaneity. Wentong has tried to transmit into Su Dongpo in words his talent in ink bamboo. In Wheelwright Bien, in Lun Bien's terms, this is the dregs of painting bamboo. Now, I think Su Dongpo is winking at us. He maybe even been putting us on. He's been using the high rhetoric of art theory and the great issues of the day, immediacy. These are really important issues in the period. And the intellectual historians take it for the bait. But all of a sudden, he drops that discourse entirely. And we get to Wentong number 2. We saw Wentong number 1, right? He's the guy that gives you the profound lesson. Now Wentong number 2. And all of a sudden, you see a different Wentong. Okay. When that's Wentong, first painted bamboo. He didn't take what he was doing seriously. I think the English term here, for those of you is doodling. He's saying like that. He's not even thinking about it. People carrying plain silk came from every direction to ask for painting and would line up toe to heel at his gate. Wentong was sick of this and threw his paintings on the ground, cursing, I'm going to make socks out of these. Gentlemen, pass this around as a good anecdote. Instead of Wentong the theorist here, who would teach others how to paint bamboo, here we see Wentong as essentially a doodler. He did not take his art seriously. 不自贵重, right? He was, I think, in the condition of a truly spontaneous, unself-conscious painter, right? That's a unself-conscious painter cannot know what he is doing, right? If you say, I want to paint not 自然的 painting, not unself-conscious, you can't do it. You can only do it when you don't know you're doing it. It's an old, probably romantic theory in the West. Okay? But if people are lining up saying, would you paint me an unself-conscious painting? I have a piece of silk. And you have a whole line of these people, all who are saying, please paint me a natural, spontaneous, unself-conscious painting. What's happening in the world, right? Those people who want him to paint an unself-conscious painting all value unself-consciousness, right? And the horrible thing is, and this is Professor Shiba's area, when there's a intellectual value becomes a social value, it also becomes a commercial value. So there's all the, and you know those people bringing silk, you know what they're bringing him, don't you? They're bringing him not just enough silk to paint a bamboo on, they're bringing him a lot of silk to paint a smaller bamboo on. Silk is money. You can get rich this way. So here the poor unself-conscious painter gets mad because all these people are trying to get him to paint unself-conscious bamboo. He has to throw his paintings on the ground and stomp on them and say, make socks out of them. And they say, oh, what a wonderful, eccentric, unself-conscious man. And the value of his paintings go up even more. You can't get away from them. Those people who want his paintings are there, always there, staring at him saying, please paint another unself-conscious painting for me. They can go sell it for more money than they spent. Right? So, we have a queue of gentry. Wantung tries to break free. He has his fit, and it just makes him even more and more interesting. I won't go into every detail in the text, but Wantung does, how does poor Wantung get out of this, right? He hates it. How can you escape when people have suddenly decided you're an unself-conscious genius? Well, there's an old good Chinese tradition that helps him escape. You can pass on your art to a disciple. And guess who gets it? Let's see if it's in this, yeah. Oh no, that's not it. It's back there. No, wait a minute, we got. Oh, I didn't. Anyway, I guess maybe I left that. Did I leave that out? I don't know. In any case, what happens is he decides, he says, go find Sudong Po. He's the new master. I'm retired. And that's the, so he manages to escape the people, and they all go to poor Sudong Po. Okay, so once the issue of commercialism has entered into this world of art theory, you can't get rid of it. You can't erase it anymore, right? Bamboo begins as an inch-long sprout in the ground or in the mine. It has a propensity to grow bigger and bigger and bigger. It's super bamboo, big bamboo. Sudong Po thinks of the material medium of representation as silk, and when the increase in size of the representation is also an increase in money. The bigger the bamboo painting, the more money the silk is worth, right? And he begins a joke again. I think this is somewhere up here. Yep. So he sends it back, and he says, at the end of the letter, he copies a letter out, and Wantung copied out a poem that said in excerpt, I plan to take this piece of Goose Creek silk, and sweep forth wintry stalks 10,000 feet long. And I told, this is Sudong Po speaking, I told Wantung, if you're going to have bamboo 10,000 feet tall, you're going to need 250 bolts of silk. I realize that you're going to wear yourself out with brush and inkstone, that is painting, simply for your desire to get so much silk. That is, Sudong Po is playfully accusing Wantung, our unself-conscious doodler, of doing painting to make money. Wantung's grand intention to paint the fully realized bamboo 10,000 feet tall becomes the silent desire to get rich. Right? The two friends, older and younger, have descended to witty banter, with Sushir as the unchallenged wit of his age and the master of all banter. Poor Wantong, when he gets Susher's joke, he says he can't deal with it. Wantong couldn't make a good retort. Let me go on here. Now, Wida, he couldn't answer him. He said, I was wrong. How could there ever be bamboo 10,000 feet tall? I followed up on this. Sudongpo is a pretty vain guy, you know. He says, I followed up this, offered a complete concrete example of how you could, answering his poem. In this world, there are indeed bamboo 10,000 yards tall. When the moon sets in the empty courtyard, the shadows are just that long. Wantong laughed and said, Susher really can make a witty case. Still, with 250 bolts of silk, I could buy fields and retire. So you see him start there, they're talking about making money. And Wantong is saying, can I really make that much money? Maybe I can. Maybe I can get rich. You can't, no one man can say that, right? But simply an old man thinking about making enough money to buy a farm. Then he said to me, recumbent bamboo of Yundong sent me the recumbent bamboo of Yundong Valley that he had painted, commenting, these bamboos are just several feet long, but they have the propensity, sure, to become 10,000 feet tall. Now, what Sudongpo has done is he's infected the discourse with fantasies of wealth. Sudongpo's couplet is a bit strained, but the figure of bamboo growing ever taller as dark shadows uncannily echoes the dark shadows of bamboo on the moon in the moonlight. The inch of bamboo in the mind has grown to any imagined height on white silk. This is propensity, sure, of bamboo to grow tall. Wantong's disavowal of his fantasy increase collapses before Susher's affirmation. At this point, Wantong starts thinking of making enough money to retire with his doodling. So Wantong, the one-time doodler, has now brought up a fantasy of 250 bolts of silk and the possibility of buying a retirement home. This is the Song dynasty. This is not the Tang dynasty, right? You can't get that money out of their minds. The elite disdain commerce, professed lofty ideals, but the realities of commerce and economic life, about Professor Shiba, is right there behind everything. And in this next poem, Susher will grow Wantong's imaginary capital to significant wealth. All this banter was the occasion for this particular painting that Susher has unrolled for his autumn airing. Wantong has found his retort, and Susher duly records it. It is the same principle with which Susher opened his essay. Although the bamboo shoot is small, indeed small enough to fit into the inch of the mind, it can really grow to huge heights, right? That's why I said, I think this is the Warren Buffett of bamboo for those of you who, this is the person who invests in a little tiny bamboo shoot, and it makes a huge, vast bamboo shoot on silk, which turns into a lot of money, right? Sure, the propensity of small things to increase. Now, Yundong Valley was in Yangzhou, where Wantong once served. And he commissioned me to write 30 verses on Yangzhou, one of which was to be on Yundong Valley. My poem went, and I think, let's see if I've got this over here. Yeah. No, this is back in the old one. I can't see it, yeah. And I might be leaving pieces out here. The tall bamboo of the river Han are cheap as dandelions. Whenever did the hatchet spare these sheathed dragons? I reckon that these feed the governor in his austere poverty. The governor is Wantong. But 1,000 acres of Wei shore are in his breast. Okay, that breast, which had the one bamboo in it, I got to stay here what sound system is, now becomes the famous bamboo that filled the shores of the Wei River near Chang'an, which the great historian Sima Qian tells us is money enough provides money enough to live like a prince. So this is in his breast. Not just bamboo, but many bamboo that become a lot of money. On that day, Wantung was visiting the valley with his wife, and they were roasting bamboo shoots for their evening meal. When he opened the letter packet and found this poem, he was so overcome with laughter that he spit out his food all over the table. So that's what happens to the bamboo, right? The bamboo fantasy of the mind becomes the bamboo spit out all over the table. The noble bamboo, right, was a signifying plant whose image invited contemplation. It was referred to poetically as Tsejun, this gentleman, right? And famous for its integrity, Jie. Also the segmented joints of a bamboo, and for its perseverance, staying green through the winter. All these good, noble things of bamboo. And also, it's a delicious vegetable. Now, how you get a vegetable that has integrity, I don't know, but that's it. It's difficult to explain a 1,000-year-old joke, but Su Shi's poem is very funny. The question of commercial value is part of the joke. Jian, translated as cheap, and everyone knows bamboo shoots are cheap in their season, is also the class term base, the very opposite of Tsejun, Jianmin, right? At first, we may not know why they're being cut indiscriminately with a hatchet. Bamboo has many uses. When we see sheared dragons, we know these are bamboo shoots. Dragons can contract into something very small, but they extend out into vast distances. Dragons can, when they're still shoots, bamboo are purpley sheaths that are shed as the bamboo grows. So the governor, Wantung, lives in noble poverty and eats cheap bamboo shoots, jian, right? But in his breast is Tsejun, the bamboo in his breast, and he has the 1,000, which turns into money, which gives him the 1,000 acres of bamboo by the Wei River. He becomes a rich man. Roughly speaking, you live in poverty, you eat the cheapest and most humble of foods, but in your heart is the bamboo, which is both a dream of wealth and that inch-long sprout that grows into the painting that which brings you more silk. Su Shi's poem chances to reach Wantung when he's having dinner. The Chinese would say this is definitely chow. It's the right moment when you find suddenly the bamboo shows up at the dinner table. And once the bamboo begins as a bamboo shoot in the breast, it comes at last the bamboo shoots in the stomach. The former, the bamboo shoots in the breast, go to maturity. At exactly the right moment emerge through the hand of the artist. Right? The bamboo shoots in the tummy were there until you tell a good joke, which has to do with making money, and then they become the bamboo shoots on the table. The former belongs to the artist, who does not know he's an artist. The latter belongs to the governor, who lives simply and in poverty, who thinks of making socks out of his paintings and eats roasted bamboo shoots. What are we to make of this? As grand as the first part is, it's hard not to feel that such a mode of offering a grand theory of art has somehow been superseded by the homier truth of the latter part. He left a lesson, E, for his readers, who wanted to Dai or Wang Yan, but those readers will continue reading to something richer. Rather than the question of immediacy in the opening passage, here we see its impossibility. We see Wantung as a doodler with pure unself-consciousness that has no sense of value in either the unself-consciousness nor in the painting of the product. But already we're in an age which values immediacy. And whether Wantung likes it or not, he has no power in this social world he finds himself in. Whether he likes it or not, that become the aesthetic value has become social value, which is commercial value, and you can't ever get away from it. Right? All this is set in the context of death and remembrance. On the 20th day of the first month of the second year of the Yuanfang reign, Wantong passed away in Chengzhou. On the 7th day of the 7th month that year, I was in Huzhou, was airing my books and paintings. I saw these bamboo. I put aside the scroll, choked with tears. Long ago, Cao Cao, sacrificial address to Qiao Xuan, used the phrases, the carriage passed, and I felt a pain in the belly. Here's that belly again. And these playful words I wrote earlier for Wantong show my feeling of perfect closeness with him. We come at last to the occasion for writing this autumn piece, the autumn airing of the scrolls. He hadn't been thinking of Wantong initially, but seeing the painting made him trace back the meaning and all that was behind it, and then finally the pain of death and loss. As Chinese readers so often did, Su Dongpo looks to the past for examples of what happened. Su Dongpo thinks of the great warlord Cao Cao at the end of the Han. Qiao Xuan was the man who first told Cao Cao that he was a genius and could rule the empire. Just like Wantong was the person who passed the art of bamboo painting on to Su Dongpo. He can't forget about he feels a pain in the belly, and you can't forget about the bamboo shoots. I began by talking about the nature of knowledge embodied in literary texts. It's clearly not the kind of knowledge offered in Wantong's lesson about knowing the moment to strike. Perhaps the best way to approach it is knowledge that we must presume in the reader in order for him or her to make sense or see the humor of the text. That's a special kind of historical knowledge in which we suddenly realize they know what we know. They can claim the values of immediacy, but they know the real complications of the world, how things are embedded in social relationships, in which those values, like immediacy, work only imperfectly. So I'm stepping back for a bit of reflection on the process, and I'm going to get out of here before it's time, I hope. We started off with a standard Chinese studies reading of the opening passage. And it sounds very wonderful image of the hawk striking and the rabbit. The nature of knowledge within the text also is the nature of knowledge assumed in the discussion. It requires authoritative master, and it will not change. Wantong's authoritative lesson on painting is a variation on conventional values. In the background is the assumption of a long phase of practice after which a mastery is achieved. That mastery justifies the lesson given to Su Dongpo. There is no hint of such mastery in the next section. The stage of mastery involves the internalization of values to the degree that action is pre-reflective. Confucius at 70. That belongs, so you can trace the Guoxue thing right back to the beginning of Chinese culture. That gives it a kind of pedigree and authenticity, a kind of weight. It becomes a Chengyu. And that's good, you see. What I realized is you need both of these. You can't do the new without speaking the old. And speaking the old without doing the new is hollow. So the two have to go together. They may not fit together, but they have to go together. And this happens over and over again in Chinese discourse. That's why I think it's very interesting. To reach a representation of the fallible human being, Sutra has to go through standard values to show something beyond them. The standard values are not false, but they're not adequate by themselves. So we come at last to a way to think about how pre-modern China could both be continuing, the old thing, if you teach Chinese and literature, you know that there's always somebody in the audience who will say, this is not a new idea, this is a very old idea. And we'll go back and give you a text beforehand, and somebody else will go back and will say, it's even earlier than that. And you believe that all knowledge already existed at the beginning of time, which may be true. So on the one side is the Guoxue notion of this China which is eternal and which continually recycles and nuances ideas. On the other side is something we can really recognize as progress, because that idea of the bamboo and selling bamboo, and it becomes a commercial value that you can't escape from. That's very sophisticated. I don't think you could say it any other way except as an assumption. You can tell a story, but that is no less knowledge, because without that knowledge, you can't read the poems, you can't read the prose section. It makes no sense at all. So those two pieces, both the tradition and the innovation, seem bound together and have to live together side by side. Thank you. And 48 seconds left to go. Okay.
Professor Yoshinobu Shiba distinguished himself as one of the most intelligent and insightful scholars in Song Dynasty history, particularly with a concentration on the commercial, economic, and the social interactions. His work has beautifully demonstrated this integration of different kind of trainings altogether. And particularly his training in Japanese sinological studies, his understanding of methodologies drawn from Western social sciences, and his excellent immersion in Chinese archival studies. By putting all the three different disciplines together, he managed to explore a new and extremely different world of the dynamics of a Song dynasty in every aspect. His study is truly interdisciplinary and cross-cultural. Professor Shiba's concentration is not merely on Song Dynasty social and economic history. He is equally an expert in urban history of a pre-modern China. And above all, in recent decades, he also dedicated himself to the studies of overseas Chinese. And in that capacity, he actually has done research on this island in connection with the old city, Tainan. So in that sense, I think Professor Shiba truly has an intimate ties to our society and our cultural circle. 斯波义信教授，他的专长是宋代的商业史以及社会史。但是除了这两项专长之外呢，他对于整个的中国从宋代以后不同时期的经济、社会以及都市变化呢，都有精深的研究。那么在过去这些年呢，他对于华侨作为一种特殊的中国在海外的个别或是群体的身份呢，也有许多专精而独到的见解。那么斯波义信教授所呈现的一种汉学研究呢，真正是跨领域、跨学科的。所以在今天呢，我们非常难得的有机会请到斯波义信教授，那么来做专题的演讲。Professor Shiba's topic for today is 中国史上的商人的社会位置 ，the social position of the merchant in Chinese history. Now, may I have the honor to invite Professor Shiba to give us his lecture. Thank you.
それでは中国史における商人の社会的地位という題で報告をさせていただきます。 私は中国語はできませんので、日本語で報告をさせていただきます。失礼いたします。私がこれまで大学院時代から行ってきた研究の焦点は、闘争変革期における社会変動について、広く言えば、まず1、中国史の悠久の経過の中で、社会構造の刷新をきたすような全面的な変動が果たしてあったのが否かと。言い換えれば、中国の歴史の流れを政治的、社会的秩序の盛衰、調和の回復の連鎖としてよりも、むしろ社会全体の動態視、ダイナミズムとして考察することはできるか否かという関心でありました。より具体的に申せば、さらに、こうした動態変化を起こさせる要素は結局何であったのか。で、その因果の連関について、資料に即して実証できるかどうかという問題に興味がありました。私は、その研究作業上の仮説として、交通と社会分業、社会分業とは、ソーシャル・レビジョナブル・レイバーのことです。それから社会移動、ソーシャル・モビリティ、それから都市化、つまりアーバニゼーションという切り口を用意しまして、この問題に取り組んでまいりました。で、大学院で勉強しておりました頃、すでに日本の2、3の先輩が闘争の変革期というものについて興味深い洞察を下しておりました。その一人は内藤コナン、それからこれをこれをさらに発展させました宮崎一貞という2人の先輩です。両方とも京都大学の学者です。それからその次に、桑原実蔵という、先生がいます。この桑原先生は桑原、フランス文学の桑原先生のお父様ですが、ルドヴィヒ・リースの直接の弟子で、リースという人はドイツのベルリン大学の地理学の先生で、そして日本に1778年から1905年まで滞在して、近代的な歴史学を教えた人です。いわゆるお雇い外国人で、この方に直接学んだのが桑原先生で、その考え方には地理学の影響が非常に強いで、私の商業研究の中で最も大きな影響を受けた方です。で、そこでこういう商人の社会的地位をめぐる通念とか社会環境とは、いかなるきっかけがあって昔から変遷したか、そして商人がドライビングフォースといいますか、社会変化の原動力となるというのは、中国史のにおける商人の地位についての常識から言いますと、誠に 変わった話であります。でそこで若干の説明が必要だと思いますので、まず市民の説ということからお話ししてまいりたいと思います。それから失礼しました。加藤茂氏という先生は東京大学の先生で、もともと臨時台湾休館調査会、南満州鉄道株式会社の事業ですが、そういう観光調査という、法律とこの慣習との関わり方を調べられる。それから後に新国行政法という、中国の行政のマニュアルを同じく臨時台湾休館調査会で研究されて、そして、結局中国の歴史書を詳しく読み、正確に読むことによって経済史を開拓することができるという方法を編み出された人です。それからで今次に移ります。漢の藩校、ここに出ている藩校が編纂した官序という正史の中に、士農工商という職能別の社会序列があって、その中では農が本業として最も尊ばれるほか、商工は必要ではあるけれども差別された社会の階層であると記しております。この市民の説というのは、さらに古くは紀元前7世紀頃、山東省の清の人漢中の作品だと言われております漢詩という諸子百科の本にも説かれておりまして、これは清という国の王様であった漢公が市民をどのように住居に住まわせたらよいかということを諮問したときに答えた漢中の言葉です。で、士農工商の市民というのは国の責民であると。責民というのは基礎、柱という意味なんです。ですから、これはこの時はですね、士農工商いずれも国を作り上げている大事な社会階層なんだと、そういう認識を下しているわけです。だからそれぞれを住まわせるということについては、市については学校に市を集めて審議に先進させるべきであると。それから農の場合は田や田畑に集中させるべきだし、公というのはこれは国の手工業を受け持つわけですから、役所の近くに住まわせて、そしてその技術は父兄からこの子どもたちに伝習させる。それから商の場合は、商人はこれは市政に宗教させて、このマーケットがあったかないかということは疑問ですけれど、まずこれはなかったというのが通説なんです。で、この市政と言っているのは、辺境にあった貿易の場所のことを言っていると思います。で、父兄から商業の技術を伝習させるべきだ。で、要するに、世襲の技術が遺憾なく発揮できるように、住居を分けてそれぞれ職能に先進させるのが一番いい方策だというふうに提案しています。で、これを見ると、 これはですね、またその同じ文章で、朝廷及び礼儀が尊敬されるためには、徴用、剣具、汽船などの階層ごとの秩序が守られることが大事であった。もし、こうした秩序、区別が守られずに、階層ごとに、許されている社史の限度も犯すようであれば、民、すなわち地の交渉からなる市民が営む世襲の権利、義務、生活様式がすべて乱れて、政府に対する尊敬が失われるというふうにしております。これが一番早い市民の説、漢中の説であります。で、シカゴ大学の貨幣隊教授は、この社会移動のことについて、優れた本をお書きになったんですが、その中で、こうした言説が現れた背景は何かというふうに解説を下しておられまして、古代において理想的であり、かつ権威のある政治社会は、西の州、世襲の制度であって、それは封建制である。で、漢中の時代には、その封建制は、もうすでに崩壊の兆しに差し掛かっていました。で、西の州は771年、紀元前771年に滅びますから、もうこの7世紀にはかなり乱れているということは言えると思います。それで、その崩壊の兆しの中で、一つは支配士族の長男、長子による家督や財産の相続、それから生まれついての階層差別に基づいて組織されてきた、いわゆる封建の社会秩序、この中に市民も入るんですが、時代の趨勢として危機に変するという、この現実や意識が確実に一方に存在した。またその一方で、このように矛盾や不平等がすでに明らかな古い社会を放置しておけば、国の存立が保障できない、危ない。で、解決のための方策や提案を緊急に講ずる必要があるというのは、諸子百科の、いろいろな説のもとであって、結局この二律背反、一方では国や社会が乱れていると、一方ではその乱れた社会は長続きできないという、そういう問題に対する回答を諸子百科は出していたんだということになると思います。それで、自己はどう言ったかといいますと、特に孟子ですが、人の生まれついての才能は元来人ごとに不平等なのだから、金持ちと貧乏、それから能力のある人ない人の別によって自然に社会の階層化が生ずることはやむを得ないと、こういう判断ですね。そこで各人の功業、功績、アチーブメンツをオープンで普遍的な方法で査定して、そのアチーブメンツの達成度や優劣を、例えば教育の機会を増やすことで、選抜をし、そして客観的に判定した上で、その手続きを経て、まず学者を選び、でその学者を士と言います。士の中から官、つまりお役人ですが、を任命すればよいというふうな解釈ですね。これは州の、そして教育の普及を土台として、平等な階層社会を創出することを提唱しております。これは中国でことさら教育が重んじられるということのそもそもの起こりだと思います。で、同化、正反対の立場は同化でありまして、同化は万物は哲学的に見れば平等なので、人も獣も木も石も、それぞれ本然の性に従って生きる限りは、高い低い、正しい間違い、 大小、強弱という、そういう差別というものは本来生じないんだというふうにしております。で、したがって人為的、道徳的な強制を、つまりそういう強制を、むしろ否定している、つまり無意にして課す、つまり do nothing という考え方を主張しているわけです。それで、ところで、西州の時代に、西州とは西の州ですね、の時代には、氏族制、時代はですね、氏族、クランシステムの時代でありますから、ありまして、政治の統合秩序とか集落の秩序から言いますと、そのパターンというのは、いい、つまり城郭都市を単位となった一種都市国家の連盟の状態というふうに考えてもいいと思います。それで、この城郭都市、つまり支配士族が住んでいた集落の単位ですが、そのUとの中間地帯はどうであったか。これは種族、狩猟とか遊牧を目的とする人たちが住んでいる粗放な地域であって、これを田とか領とかいうし、あるいは山川、藪、沢といったような、農業に向かない土地であるというふうに関連されていまして、この当時は、その遊牧民とか狩猟民とか漁業民、森林に住む人たち、これは広告の民、広告というのは、行くという字と、つまり移動して定住していない民というものに数えられていまして、漢族は城の中で住んでおり、これは定住民です。で、そのために、この今、市民と言われる中の農民ですね、農というのは、これはすでに農耕民としてすでに存在したとは思いますけれども、城郭内に住むというよりは、城の近く、近郊、あるいは俗有小さな城郭都市の中に住んで、社会地位も農土に近い状況であったというので、後世のように独立した農民がそこら中に住んでいてですね、それを考えて農と言ってるのではないと私は思います。それから城郭の中には支配士族とその家族、それから青銅器や国旗、木器などを製造する手工業者が多数いる。これこそはその国が成り立つための非常に大事な要素であります。で、その地位は奴隷に近いものであったと思いますが、その他に商人、商業もこの当時の国を成り立たせるためには必要な存在でありまして、つまり都市国家なんですから、それは必要な存在であると。そして城郭内には後世、つまり秦や漢の時代以後のような政府のコントロールスイッチというものはあったかとは思いませんけれども、国境でご私貿易が行われておりましたから、商人はそうしたところに集まったというふうに考えております。で、つまり漢中が言っている市民というのは、封建制度の中で、世襲的で、親からの商業を守って、自分の役目を果たすという、そういうタイプの 職業文化のことを言っておりまして、商工業者というのは国や支配民族の士族の存立ために必要不可欠な存在であります。責民というんですから、その限りで活動を認められていたわけですけれども、例えば、漢の時代の司馬遷の史記の過食列伝などを見ますと、すでにこの、都市国家の時代から商業者の活動というものは記録の中に残っております。例えば、古のかの王朝の民というものは、商業の技術に優れていて、その子孫が漢代の都市にも住んでいたということは、そこに記録されております。そして、また、司馬遷によりますと、巨万の富を築いたと。でも、この一方で、世襲の制度の下で、親代々の職業をしていたと言われているこの時代にですね、実はいくつかの有名な大商人の例が挙がっております。それは、例えば、先ほど述べました漢中という人は、西の国の大夫というのは士族長ですけれども、奉祝賀と一緒に商売をして、河南省の南陽まで行って商売をした。それから、越という国の大将の藩令はですね、唐という国に行って、名前を東志公と変えまして、そして10年の間に3度も1000金に上る利益を上げたという話があります。また、ロの国にはイトンという大商人がいました。そういう話がありますから、市民制度のもとに商人の地位が非常に低かったと言ってもですね、それは制度そのもののことを言っているわけであって、現実に商業行為が行われておって、そこから大きな利益を上げる人たちがいたことは間違いなく言えると思います。ちょっと待って。で、時間がありませんので、次のお話に移ります。交通と社会分業と。で、中国史の中で、社会で生きる庶民の日常生活に変動を引き起こしたような技術変化としては、いろいろあるんですが、私は中んずく交通通信の変化というものに注目したいと思います。で、近代的な交通技術が中国にもたらされたのは19世紀でありまして、無線電信とか蒸気船、それから汽船、汽車といったものが交通の大革命を引き起こしたわけです。で、それ以前ではどうであったかということになりますと、隋唐の時に行われた水運、それから海運、海の海運、そうですね、海運における変革の意義というものは、技術変化の中では非常に大きかったというふうに思います。で、隋の610年に大運河が完成しまして、海邦洛陽から広州寧波まで水運が全国に通じました。で、 これと並行して首都を起点として時計回りにですね、大体8本の基本の路線ができまして、そういう交通のネットワークというものは基本的に整ったということをまず指摘できると思います。そこで問題は2つあります。その交通が発達した結果、商品といいますか、地方の資源の特産化が進んだということですね。でこれはその特産物が登場すれば商品が当然起こってくるという、そういう自然の現象です。第2はですね、この交通の発達と商業の発達というものを国家がこの問題に適応して、そして大きな変革をしている。これは中国史でもこの時期が初めてなんですが、中国が北方から遊牧民族が侵入すると、これに対抗して軍隊を作るときにですね、古代からというか、漢の時代から隋唐まで一貫して、基本的な方針は農民歩兵を養成するということです。これにこの問題からですね、この唐の半ばを過ぎますと、ちょうど起こってきた水運、海運という交通の改革と、またその商業活動の勢力を利用して、いわば合弁の形で、それを国家がその交通商業の発達にうまく適応して、新しい軍事制度を作り上げたということです。それは7世紀頃からその背景としてどういう水運が起こったかと申しますと、唐の7世紀頃ですね、政府が商税を施行するという案が出てきました。でこれに対して蔡瑀という官僚がそういった文章をここに挙げております。これを読みますと、水運がですね、全部つながっているという、これ非常に大事なことなんですが、水門とか堰とか水位を調節装置があって、黄河から落水、そして南の大運河を通って南方の揚子江につながる支流とか、いくつかの川はですね、すべてをつながっているんだというふうに議論しているんです。それでだから大運は大運河だけの発展じゃなくて、その大運河を含めて河北、河中、河南の水運は、一つの一体となっている。そして水運労働者が起こり、水運業者が起こっている。だからもし徴税をかければですね、その水運業者の利益が減り、そして労働者の反乱が起こると、そういう物騒なことが起こるんではないかというふうに、そんな観点から反対をしています。それから先ほど申しましたが、交通が起こるとどういうメリットがあるかというと、これは資源が地方にそれまでバラバラにあった資源が交通の力によってですね、それぞれ地方ごとに特産化し、 それぞれの市場、市場、マーケットができてくるということです。で、これ地域間の交通の発達によって、出稼ぎが多くなるということはもちろんですが、その中で商人が活動しまして、彼らはその地域の値段を差異によって設けるわけですから、全国的な評判のある商品、それから地域的に評判の高い商品が揃ってくるということがですね、これが商業活動の非常に大きな前提になっているわけです。で、ここで交通の改良によって、そういう全国的規模で地域の特産物の市場が広がったということは、これ間違いのないことであろうと思います。それで、その次に、特産物市場といいますが、地方ごとの名産物産のリストがですね、大体分かってきたということです。で、ここに挙げておりますのは、宋の時代の都が開放というんですけども、北宋の時代です。その時に全国的に見渡してですね、この商品はこれしかないと、右に出るものはないというふうにしたのが、この28ぐらいあるんですが、ここに14ですね、28。で、それぞれ見てみると、なるほどと思うところがあるんです。で、それから後で、宋代には交通と商業が発達したために、広く需要され消費される物資の中で、おのずからですね、全国的な評判の高い商品が出てきました。で、首都の開放の人、太平老人と人の随筆ですけども、集中金という本があるんですが、その中に天下第一というものを掲げております。これがここに挙げた28種類のものです。で、この中で面白いのは、皆、家中河南の特産物が非常に多いということなんですね。それから、福建省の産物が結構この中に多い。例えば16番がそうですね。それから、25番の福建秀才というのは、これは秀才っていうのは唐の時代からあるんですけれども、科挙の場合、試験で秀才科というものを受ける。で、これはあまり評判は高くはないんだけれども、合格がしやすいというか、それで福建の人はこの秀才科から科挙に入ったということがよく言われているんですね。これを社会移動というんですが、このことは後で申し上げますから、この程度にしておきますけれども、社会移動とは何かといえばですね、これは人材を輸出すると。で、商売ですと、その地域の資源を輸出する。で、外地へ輸出して、収益を上げるということなんですね。それで、この闘争時代に、非常にこういう、交通が発達し、そして地方が特産化して、で、資源を外地輸出する。それは当然商人の発達ということになってくるんですが、それからそれと合わせてですね、人材を外地に輸出して、地方の名誉を高めるということで、非常に熱心だった、一種の社会心理ですが、そういう戦略を取った地方がいくつかあります。その中に福建地方がありますので、福建のことをちょっと詳しく申し上げたいと思います。それから、ここに書いておりますように、 福建民代までを視野に入れてみますと、この科教試験で成功して役人になれた、その成功率の高い地方とはどこかというと、これはちゃんと数が分かっているんでして、第1位は厚生省ですね。それからその次は浙江省と、それから放送省、福建省と、福建省は 4番目に入っております。で、このことはすでに宋の時代から例えば哲学者の朱子なんかはそのことをすでに言っておるわけでして、ここでですかね。朱子はどうか。一つ面白い宋代の役人の言葉で挙げておきたいと思いますけれども、それは例えばさっきオーウェン先生が外馬のことをお書きになったっていう、祖職はこれ福建というところは海の商人で商売にしていると。で福建を代表する職業は海上商業だというふうに言ってます。これは非常に面白い発言であって、例えば日本と中国との貿易というのは唐の時代はいわゆる遣唐使ですが、遣唐使は初めは渤海湾に沿って島伝いというか陸を見ながら行った。ところが733年頃からですね、沖縄本島をちょっと過ぎたところから東シナ海を直接横切って寧波へ行くようになったんですね。これは理由はいろいろあるんですけど、はい、それはね、やはり中国側の商人がそういう海を直接渡って日本とかあるいは朝鮮半島の国領ですね、公領とそれをいうところと盛んに貿易してました。なぜかというと宋が始まるちょっと前に五代という時代があって、その頃五越国という国、あるいは南韓国とか、これは福建の方ですけども、それから江南東国は盛んに海外貿易を行って、そして国の富を上げました。でそのやり方をはい、そしてあともう時間が来ておりますから、最後のところだけ読み上げますけれども、祖職は福建一路解消をもって業とするというふうに述べています。海運業こそは福建商業を代表する職業でして、交通と分業の刺激のもとに福建が生み出した究極の地域ぐるみの新しい職業でした。でこの勢いが順調にもし明代清代と引き続いて発展しておれば、あるいは近代的な商業、ちょうどイタリアにおけるベニスとかジェノアによく似ておるんですが、そういうようなケースで例えば銀行業が起こるとか、海運業から大資本家が出てくるとか、そういう ケースはですね、復権を基礎に起こったんではないかと思っても別におかしくはないんです。で、そしてそういうわけでして、交通と分業の発展はこのようにまずマーケットを広げます。そしてマーケットを広げた上で経済的社会的な環境条件が整ってくるということも非常に重要なんです。で、それ先ほど申しましたが、軍事補給、プロビジョニングとかロジスティックスとか、そういう兵隊を国の防衛に関わって交通、それから商業の力を国が借りて、合弁の形で営んだと。でこれはまあそういう特別な時代だったと。宋代から明の全般まではですね、そういうロジスティックスというのが中で商業、商事制度、例えば為替だとか紙幣制度とか、そういったものも発達するし、それからお茶とか塩とかですね、それから香料などの専売をそのロジスティックスに組み込むとか、そういう制度が盛んに行われた。でしかし残念なことに明の初期にですね、この海運、せっかく起こっていた宋代の復権を中心とした海運業というのは明の対その政策によってですね、貿易を抑圧されて、それからあと明の後半になると旋回令というものを行われましてですね、そしてせっかくの起こった動きというものは実を結ばなかったということは言えると思います。でしかし
読まなくていい、読まなくていい、
ちょっと
読まなくていい。
ちょうど時間になってまいりましたので、私のお話を十分申し上げられなかったんですけれども、大体交通が発達し、分業が発達しですね、そして経済体制、そういう社会心理、自然の資源を輸出する、それから人材を輸出するということが一つの地方の方針となって、そして今言いましたのは福建なら福建浙江省とか、そういう地方独特の文化が発達したということが私の申し上げたいところであります。どうも失礼いたしました。ありがとうございます。
Ladies and gentlemen, we just listened to very, very illuminating lectures, one on the art and the value of bamboo in terms of multiple perspectives of artistic understanding and undertaking, friendship, and of course bamboo as the motif of a traditional Chinese painting. And the other one deals with the genealogy of the merchant, particularly focusing on the Song dynasty. Amazingly, the two lectures are actually related to each other, not only focusing upon the Song dynasty, the social, economic, and cultural interrelated relationships, but also demonstrated how sinology really is a discipline highlighting the interdisciplinary relationships among various subjects and matters and periods and areas and methodologies. Let us just give these two distinguished scholars another warm hand. Thank you very much for your contribution, and we congratulate you again on receiving the great honor of the Tang Prize. 我想这两位学者呢荣获唐奖实至名归。我们今天非常的荣幸在这里聆听两位大师对于和宋代有关的艺术以及商业以及相关的不同的学术研究领域的综合性的报告。那么在这里呢，再一次的谢谢他们为汉学界所做的贡献。那么演讲结束呢，也容许我再一次的也谢谢大家到场聆听这一次难得的盛会，在此告一段落。谢谢，谢谢。
谢谢王院士为我们主持。Thank you very much, Dr. Wang, for hosting this lecture session for us. And thank you again to our laureates, Dr. Owen and Dr. Shiba. Ladies and gentlemen, this is the end of the Sinology lecture. Thank you very much for your participation. If you have any questions regarding this lecture, you're welcome to join the press conference on the first floor. Please don't forget your personal belongings as you leave and return the interpretation headsets on your way out. 各位来宾，第3届唐奖得奖人演讲汉学场到此圆满结束，非常感谢您今天的参与。若您针对演讲的内容想要提问，请移驾至1楼的前瞻厅。离场的时候，请记得您随身携带的物品，并归还您所借取的同步口译接收器，取回您的证件。谢谢。